Through our everyday experience, we can actually tell, without even looking at the video, what must be happening in the video, just by the sound of the car racing towards us and then moving away. This is what we have experienced in our daily life. Even though the car here is a race car, the same is applicable to a normal everyday car. As the car moves towards us, its pitch or the frequency of the sound gets higher, whereas as it moves away, it gets lower. So this is known as the Doppler shift or the Doppler effect. Let's take the scenario when the car moves away from us. Each successive trough and a peak as the car is moving away from us, it has to travel more because of the speed of the car, and hence the separation between each wave gets larger and larger. Hence the frequency decreases, and the opposite happens in front of the car, hence the frequency increases. The same for a light wave. As an object moves towards us, its light gets blue shifted because blue has a higher frequency, whereas when the object is moving away from us, it's red shifted because of the lower frequency. When astronomers look up in the night sky, they don't just look at the light coming off from the object, they also look at its spectrum. When we pass the light coming off from an object, that's a star or nebula, any object, through a prism, we can see a continuous spectrum which has these black lines, and these black lines give us the information about what elements are present inside the gas of a nebula or the star or whatever the object is made up of. Each element has its own combination of the spectral lines. So when we look at the object receding from us, the light coming off the object actually looks the same, but when we look at the spectrum of the object, we know how the spectral lines should look like of each element when the object is at rest. But when we see the spectral lines move towards the red end or the blue end of the spectrum, we can tell what the motion of that object should be relative to us for the spectral lines to move the amount it is moving. This happens for the same reason why the sound waves of our car were getting bunched up as it was moving towards us and getting further away when the car was moving away from us. This is what we call as the red shift or the blue shift. These spectral lines, absorption or emission lines, are unique for every element. It's like a fingerprint of each human being. To learn more about the spectrum lines and what it actually means, I have a video on it. I'll put the link in the description, or you can click the video on the screen right now. So for an astronomer, just by looking at the light of any object, you can decode its speed and what elements are present in it, and even its temperature. That's a really impressive amount of information to get out just from the light of the object. So yeah, that's it for today. Please do like the video, share the video with your friends. I make a new video every Thursday, so please hit the bell icon and subscribe to my channel. And as always, stay curious, stay awesome.